we're going to go ahead and get started. As a comment, section 3.5 is due today. Somebody emailed me letting me know that the date was wrong in my labs, so I got that changed. So it's good to go. Section 3.5 today, and you can go ahead and schedule that exam too at any point in time. You need to schedule it somewhere between the 19th and the 21st, just as a reminder. And what I actually want to start off with today is I was keying up the R2 review to date that's due on Saturday, and one of the problems there is a little sneaky, so I thought maybe we would take a look at it first. So I know you have not looked at it, but this is the R2 that's due Saturday. I want to work one of the problems. This is actually problem number 2. And what it says is to solve, and then it asks you to find both, it actually says find all solutions, both real and complex. I just want to find the real solutions. And mainly that's because we didn't talk about how to find the complex ones yet. So it's x to the 6th minus 7x cubed minus 8 is equal to 0. We will come back and revisit this type of question in chapter 5, but we're not there yet. So what we're going to do is a substitution. So we're going to come in and let u equal x cubed, so that you end up with u squared minus 7u minus 8 equal to 0. And then it factors, and it factors fairly easily, which is nice. So factors of 8 that are going to subtract to 7 would be 8 and 1. So u with an 8, u with a 1. And because we're subtracting to get to the middle term, the bigger factor takes the negative, the smaller factor gets the opposite. So u equals 8, u equals a negative 1. And then you unsubstitute. And we've done this. The sneaky part's coming here in just a minute. Okay, so at this point, you can come in and cube root both sides. And that's going to give us x is equal to the cubed root of 8, which is 2. Same thing on the other one. X equals the cubed root of a negative 1, which is negative 1. So I get these two answers. These are the only real solutions. But if you take a look at it overall, we're going to notice that it has an x to the 6th thing back up here. And an x to the 6th means that it should have 6 solutions. So the other 4 solutions are actually imaginary solutions, which we just have not really talked about yet. So just as a comment, the other 4 solutions are imaginary. They involve an I. So we just haven't done it yet. So in terms of the directions, just find the real solutions on that problem. We just haven't done it. So, and then there's another one I want to talk about. Is everybody okay in terms of what the confusion is? The directions say to find all solutions, both real and complex. I just want you to find the real solutions, and we just did it. So we did one of your 19 problems. So, okay, the other one I want to do is an application problem from chapter 1. And it's different from the ones we did. It's enough different that I'm worried about it. So this is number 3. It says that a motorboat heads upstream a distance of 24 miles on a river whose current is running at 3 miles per hour. The trip up and back takes a total of 6 hours. Assuming that the motorboat maintains a constant speed relative to the water, what was its speed? So we did do some similar to this. The difference here is though they actually give us an amount of time where they didn't in the previous problems. So we're going to let R be the rate of the boat, or the speed of the boat. So we know they give us that the speed of the water is 3 miles per hour. So that's the rate of the water. Okay. So if we're going upstream, that water is fighting against us and slowing us down. So we're going to take the boat's speed and subtract off the speed of the water. And if we're going downstream, we get to add that on because it's pushing us along faster. So then what we're going to do is make that little chart that we had used clear back in chapter 1 when we did this section 1.7. So we have our upstream We have our downstream. Okay, so we know that when we go upstream, we just said it was r minus 3. We know when we go downstream, it's r plus 3. So that makes sense. We did that. They then tell us that we're going to head upstream a distance of 24 miles, and we're going to assume that we're coming back downstream the same distance because you want to come back to your port or your dock. The other piece of information is it takes a total of 6 hours. Okay, so it's different because the 6 is over here, and we have this number over here. So to solve this problem, what we have to recognize is we know that distance is rate multiplied by time. This is an unknown sitting over here. So I'm going to take and solve this little equation for time. So time is the distance divided by the rate. So in this spot, we're going to take our 24 miles and divide it by the rate of r minus 3. In this spot, we'll take our 24 and divide it by the r plus 3. So we finally got the chart filled in. Notice that that's different from what we did before. What we're going to use, though, is the same last column, though, in order to write it. So we're going to recognize that the time it takes us to go upstream plus the time it takes us to go downstream is going to be equal to that 6 hours. So we're going to set 24 over r minus 3 plus 24 over r plus 3, and we're going to set that equal to 6. And there's your equation. So I'm going to leave you to solve it, but that's our equation. So the time upstream was 24 over r minus 3. The time downstream is 24 over r plus 3. And those two times together have to equal the 6 hours that it takes you for that trip. So, okay. And the rest of it should be okay. But when I was keying it up yesterday, it's like, oh, we didn't really do one like that. So, okay, any problems with that? Okay, and that's due on Saturday, so you can do the rest of it and get it sent to my Gmail address on Saturday by the 11:59. Today we're going to wrap up section 3.5. So as a reminder, what I'm going to do is I'm going to write the 8 functions on the board, and I want you to go do a quick sketch of them. So do you know what each of these are going to look like? So what does f of x equal x squared look like? So graph that out really quick. And then we'll do f of x is equal to the absolute value of x. So graph that one out really quick. We'll do f of x is equal to the square root of x. The next one we'll do is the cubed root of x. F of x is equal to 1 over x, the reciprocal function. You should also know what f of x equals x cubed. That's a 3 looks like. We also have f of x is equal to just x. And then our last one is f of x is equal to just some constant, and we'll pick on -1. And what that looks like. Okay, so you quickly sketch those in for me. Okay, is everybody good? I hope. So somebody describe to me what the graph of x squared looks like. What do we call that shape?
The U-shaped. It's
A
I
U-shaped.
forgot the name of it, but it's the U-shaped.
Yeah, it's the U shape, and that's all I really care about is that you know it's a U shape. But it's called a parabola. I mean, these are new words to you, right? They're not something that you use in your everyday language. So, okay, what about the absolute value? What shape would it be?
V.
Yep, good job. It's our V shape. And what about the square root of x? So if you had to describe it using words, what would you say?
Is that the one that starts at 0? Right.
Mm-hmm. So it looks like a half a U. So it's this parabola turned sideways but cut in half, right? So it's a half a U. Okay, what about the cubed root of x? So that guy is our S shape turned sideways, so it looks something like that. It does go through the origin, so. In fact, most of these go through the origin, not all. Which is the other S shape?
X cubed.
Yep, so x cubed is our other S shape, and it goes like this. And again, you can figure out which one's which by just plugging in a couple of points, you know, plug in a +8, you'll get a negative, you'll get a 2. Plug in a 2 and you'll get an 8. So. Okay, what does the 1 over x look like? What's a descriptor for that?
Bow tie.
Yep, bow tie, beautiful. And what about f of x equals x? So that one's our line that cuts through at a 45-degree angle. So just y equals x. And then what about the last one, f of x equals a constant, in this case a -1. What kind of line is that guy?
Horizontal.
Yep, down here at -1. Beautiful. And again, those are the toolbox or our library of functions. So if you worked on the homework, you did a little bit of transformation with this stuff. So let's do some more transformations with this stuff just to get used to it. We laid our groundwork yesterday. Okay, so what I want to do today first is we're just going to describe in words each of the transformations. So each transformation. Okay, so what we're going to do is y equals f of x plus 7. Okay, now the difference is that I'm not telling you which of the toolbox functions we're using. I'm just saying that you've got a function, and on the inside of that function is an x plus 7. So the notation I'm using here is different from what we used yesterday. That's why we're doing more of it today. So you'll notice that all of this is written inside of the function or inside the set of parentheses. And that's what's telling you that this change is still on the inside. So regardless of what the function is, we know that that change has happened on the inside. So what is that going to do to the graph? How are we going to shift this graph?
Right 7?
Not right.
Or
Remember,
left 7?
side you do the
Yeah, it's
opposite it says. So left 7. Exactly it. So whatever that picture looks like, we're going to pick it up and move it to the left 7 units. So yeah, let's write our quickie kind of reminder about whence everything is. So if it's outside, it's in the y direction, and you do what it says. It says if it's on the inside, you change in the x direction and you do the opposite of what it says. So inside x, do the opposite, outside y, do what it says. The analogy, I've never come up with a good analogy that everybody seems to like, but one of the analogies that I tend to use in class is it's kind of like a like my 15-year-old, like a teenager. If he's inside the house, he does exactly the opposite of what I tell him to do. If he's outside the house and he's with his friends, he does exactly what they tell him to do, right? So as an analogy, I don't know if that works or not, but that's it. So if you're inside, you do the opposite. If you're outside, you do what it says. Okay, what if we have y equals a -1/2 f of x? So again, I don't know what the toolbox function is. I just know that I need to take into a -1/2 times that toolbox function. So is that -1/2 inside or outside?
Outside?
Yep, it's exactly it, because it appears in front of the f and it's not inside the parentheses next to the x. It's considered to be outside. So we know it's going to affect our y values. So let's deal with the negative first, because it's the first thing we see. So anything that's a positive y value, it's going to make into a negative y value and vice versa. So that's a reflection across the x-axis. So it's changing the sign on y, which reflects across the x-axis. Good. Okay, and then I have a 1/2. So the 1/2 is 1/2 times. So what that's going to do is take all of my y values and multiply them by 1/2. So if I multiply by 1/2, aren't I getting shorter and shorter and shorter? So that 1/2 translates into a vertical shrink or compression, your choice of words. Shrink by 1/2. So that's telling everybody that you're going to come in and take your y values and cut them in 1/2. Okay. And this is something that takes practice. What if we have y equals 3 times f of x, and then I'm going to do a -5 after that. So 3 times f of x minus 5. Okay. So I have a 3 and I have a -5. So are they inside or outside? Let's deal with the 3. Is the 3 inside or outside?
Outside.
Good. What about the -5?
Would it also be outside?
Yep, they're both outside. So everything we're doing here is again in the vertical direction. So, and again, order doesn't matter, but I tend to multiply before I add or subtract. So let's go ahead and do the 3 first. This is saying we're going to take all of our y values and we're going to multiply them by 3. So if I take a y value and multiply it by 3, it's going to get bigger. So that's a stretch. So we're going to do a vertical stretch by 3. So every y value is now 3 times larger. Okay, what about the -5 at the end? That's going to then shift how? You're shifting things in the y direction. You do what it says, and a -5 needs to go down. So we're going to shift down 5. Good. Comments or questions about those guys? We're going to do one more and then we'll move on. How about y equals f of -x? So f of -x. Okay, so is your negative inside or outside?
Inside.
Good. And because it's inside, we know to do the changes in the x direction. Now, what this is saying is this is taking your positive x's and making them negative x's. It's changing the sign on the x values. And if you go to change the sign on the x values, then you're reflecting across the y-axis. So we're going to say reflect across y-axis. Okay. Woohoo! Any comments or questions about that? So I like writing them out in words because I think it's a quicker problem than actually plotting points and things like that. So on your review to date for the week, you're going to be doing it in terms of words. So that's what we're talking about here. Okay. Let's move on. Take a look from a different point of view. I'm going to write my little comment. Well, you got it in your notes, so we're good. I can get rid of it. Get rid of that. Okay, now we're going to go back and pull in those toolbox functions. So what we want to do is we want to sketch each of the following transformations. So we're going to sketch each transformation. And that means without a calculator, so we're not doing this on our calculator like we did yesterday. So without the graphing utility. So the first one I want to do, let's do f of x is equal to x minus 1 quantity cubed, and then I'm going to say plus 2. So x minus 1 quantity cubed plus 2. Okay, so it's the same thing we were just doing, but this time they actually want us to graph it. So first of all, what shape is it?
Parabola.
For a cube?
Oh, it's the S. I thought it was a
Yes,
two.
yeah. Yeah, I don't know. Somehow or another, my board looks like it's gotten moved off its tape flooring. If that makes it any better. I don't know. I don't know if that worked or not. Okay, so we know it's our cube shape. So again, what we're thinking is we're going to start with this picture, and this point right here is at 0, 0. So what am I going to do to that one point? It's the only thing I have to manipulate. What can I do with it? So this is telling me to move it how?
Up 2.
Good. So we know we're going to go up 2. That's this guy because it's outside. What about this guy on the inside?
Right 1. No.
Beautiful.
Yeah. Oh.
Because it's on the inside, we do the opposite of what it says. Since it says a -1, we're going to do a +1. That's exactly it. So literally all we're going to do is we're going to take the point that was at 0. We're going to go right 1, and then we're going to go up 2. So I'm taking the point that was here at the origin, I'm moving there, and then I just come in and draw the shape. It's a sketch. That's all I'm doing, is I'm just sketching it. So you could plot other points. You'd have to plug numbers in. The other points we could move would be the point that was over here at 1, 1. You could do the same thing. So you could move it 1 and then up 1, and it would be over here, right? So you could plot a couple other points if you wanted to. The idea is you're just doing a sketch. So nice. Good job. Let's try another one. So part B, let's do f of x is equal to a negative absolute value of x and then -2. So a negative absolute value of x and then -2. Okay, what do you got for this one? What shape are we starting with?
V.
Yep, it's our V shape. And again, it starts at the origin, so we have that point 0, 0 going on. Okay, let's talk about what's happening. You have a negative here and you have a -2 here. Are they inside or outside?
Outside.
Yep, they're both outside. Okay, so we know that this -2 is going to go down 2. Okay, what about that negative that's out in front? So again, we're changing things in the y direction. You're taking anything that is positive in y and making it a negative y. So we're going to flip it down. So we're going to reflect across the x-axis. Okay, so instead of opening up, it's now going to open down, which is really hard to do. So it's going to open down, and then we're going to move it down too. So I'm going to take the point that was at the origin and move it down to 0, -2, and then draw in my shape, but this time opening it down. So I reflected it, which made it open down, and then I shifted it down too. Good. Questions or comments? In general, students tend to like the transformations because they're very straightforward. There's not anything ugly or hidden in it. Okay, so part C, let's do f of x is equal to a negative cube root of x. So that's a negative and that's a cube root. It may not look like it, but it is cubed root of x. There we go. So the cube root is the sideways s. So it normally looks like that. What's the only thing we're doing to it? What is this negative going to do? Is it inside or out?
Outside.
So if it's outside, it changes things in the y direction. So it's going to reflect it across the x-axis. X. So that's going to take the piece that would have been down here in quadrant 3 and move it up to quadrant 2. That's the flipping over here. The piece that was in quadrant 1 is going to get shifted down to quadrant 4. So it looks something like that, but still goes through the origin. So all we did is flip it top to bottom. Okay, you guys are being really quiet this morning. Okay, what about part B? F of x is equal to the square root of x minus 1 minus 1. So the square root of x minus 1 minus 1. So this time we got multiple things going on. Okay, so the first minus 1 is on the inside. The second one minus 1 is on the outside. So what is the one that's on the inside going to do? It's going to shift the graph.
To the right one.
And the other one's going to shift it Down 1? And remember that the square root is the half a u to the side. So literally all we have to do is we have to take our point that was at the origin. We're going to go right 1, and then we're going to go down 1. And then we'll draw in the half a u shape. So it looks something like that. Okay, how are we doing on these guys? Okay, if they give me the toolbox function, I can sketch from there.
Yes.
Okay. So now we'll switch gears again. Now this time what they're going to do is they're going to give me the graph of a function, but it's not one of our toolbox functions. So it's just a function that somebody made up. So this is what f of x looks like. So I have some points, 1, 2, 3, 4, 5. So the first point is over here at -4, -2. The next point is at -2, -2. It goes up to the point 1, 2. And then it comes back down to the 4, -2. So we basically have those 4 points that we've got labeled. It is a function because it passes the vertical line test. We could talk about where it's increasing and decreasing, where it's constant. We could find its maximum. It does not have a local minimum because there's no bottom to it that goes back up. So we can do all kinds of things about it, but what we want to do is use this function and transform it by shifting it around. So now that you've got that, the first thing we're going to do is do y equals f of and then x plus 1. So I'm back to the function notation versus our toolbox notation. Okay. So y equals f of x plus 1. So is that plus 1 on the inside or the outside?
Inside, or yeah, it's on the inside.
Okay. So because it's on the inside, so we know it's on the inside, what are we going to do to the graph? That's going to shift how?
Left 1.
Beautiful. Okay, so I have to take that picture and basically shift the whole thing left 1. So the point that's at -4, -2 is now going to be over here at -5, -2. And the only reason I'm labeling it is just so that we can make sure we're all in the same spot and all in the same location. Okay, the point that was at -2, -2 is now going to be over here at -3, -2. So you can see that I've gone left. The point that was at 1, 2 is now going to be over here at 0, 2. And the point that was at 4, -2 would now be at 3, -2. Again, you don't have to label the points. It's just mainly so we can talk about it and see how I'm doing it. So, yay! Any comments or questions about that? It's much easier to describe in words. These are a little long. They take a little longer to do. So, but you'll see when I'm on the homework. Okay, part B, let's do y equals f of x, and then outside of that, we're going to write the plus 1. So I put the plus 1 in a different spot, just so everybody can see it. So f of x plus 1. So we just said that this was outside. So what's that going to do to my picture?
Down 1.
Not down.
Or up.
Yep, if it's outside, it does what it says. So we're going to go up 1. Okay. So I'm going back to the original. Okay, so back to this guy, that's my original. And I need to take each of my points this time and move them up 1. Well, so the point that's at -4, -2 is now going to be at -4, -1, because all I have to do is move it up 1. The point that was at -2, -2 is also at -2, -1. The point that was at 0, I'm sorry, was at 1, 2 is now going to be up there at 1, 3. The point that was at 4, -2 is now going to be at 4, -1. And then I draw in the same exact shape. So again, the shape itself is not changing. All we're doing is moving it. So good job. Okay, so we saw a left, we saw an up. Any problems with either of those? They're time consuming, but they work. Oh. Sorry, it seems like my internet connection is unstable. And I'm plugging the computer back in, it just gave me my error message. It's goofy. Gives me an error message when it's low. It tells me that if it's too charged up, it's not good for the battery. So there's no winning. Okay, let's do a reflection. So part C. Let's do y equals f of -x. So f of -x. So is that negative on the inside or the outside?
Inside.
Okay. So if it's in, it's going to change the sign on the x. Because on the inside, it does the opposite of what you say to the x value. So instead of multiplying by a -1, we're dividing by a -1, but the net impact is the same. So we're just going to come in and change the sign on all the x's. Okay, so what's that going to do? So back to the original, the point that's at -4, -2, I'm just going to take the x value and switch its sign. So instead of being a -4, it's a +4. So that first point is now over here at 4, -2. Our second point, moving from left to right, was at -2, -2. I'm going to change the sign on the x value, which is going to make it a +2, -2. The next point we're plotting is at 1, 2. We're changing the sign on the 1, so now it'll be a -1 with a 2. And our last point, which was a +4, -2, is going to become a -4, -2. So -4, -2. So you'll see the reflection across the y-axis occurring, right? So that's what we said that negative on the inside does. It reflects across the y-axis, and there it is. So we've just flipped this from left to right. Nice. Yeah, the one thing we have not done a lot of is the stretching. So let's go do a couple of those to make sure you understand the stretching and the shrinking. This would be part D. So we would have y equals 2 times f of x. So 2 times f of x. Okay, is that 2 on the inside or the outside?
Outside?
Good. And because it's outside, we know it's going to change things in the y direction. So what we're really going to do is multiply y by 2. So every single y value is going to get doubled. Okay, so the point that's at -4, -2, all I'm doing is taking the y value and doubling it. So -2 doubled is a -4. So my first point is going to be down here at -4, -4. Our second point is still going to be at -2, but now it's going to be down there doubled in terms of y. So it's at -2, -4. The point that was at 1, 2 is going to go up to 1, 4 because you're doubling the y. And your last point that was at +4, -2 is now going to be at 4, -4. So we can see that vertical stretch happening because we've taken our picture and stretched it in the y direction. So we've multiplied every single y value by 2. Comments or questions about that? Okay, one more. So let's do, this would be part E. We're going to do y equals a -1/2 f of x. A negative 1/2 times f of x. Okey-dokey. So that negative 1/2 is what? In or out?
Out.
So the negative is going to do a reflection. The 1/2 is taking all the y values and cutting in 1/2. I'm going to do it both in the same step here. So what we're going to do is we're going to multiply each y by a negative 1/2. So the negative will do our reflection like we think we should be doing. Okay. So we're not touching the x's at all. The only thing that's changing here are those y values. So we're going to take the first point that was at -4. The y value of -2, we're going to multiply it by a negative 1/2. So what's -2 times negative 1/2?
1.
Yep, positive 1. So we're going to be over here at 4, comma 1. So -4, comma 1. Good. Okay, the point that was at -2, comma -2, we're going to now be at -2, comma 1, because you're doing the same thing to the y value. The point that was at 1, comma 2, we're still going to use our 1, but if I take that positive y value of 2 and multiply it by the negative 1/2, we're going to end up where? So 2 times the negative 1/2 is a -1. So we're going to end up at 1, -1. So that's this point here getting transformed down here. And then finally, our last point that's at 4, -2 is going to be back up at 4, comma 1. So again, you're not changing the shape. So you still have the straight part, and then you have some increasing and decreasing. So it looks something like that. So we've flipped it top to bottom, and then we shrunk it. Okay. Any comments or questions about the transformations? And that's everything that should be on the homework. You'll do a couple of these at the very end of the homework. And they're the ones that are time consuming because you're literally plotting point by point by point. So that takes a while. That's it for section 3.5. Anybody got any comments or questions? Okay. Okay. I will be sending out lecture notes for
I'm good.
tomorrow. Tomorrow's section 3.6. We're doing building models of functions, which means that basically what we're doing are word problems. So I'll send that out this afternoon or in just a few minutes. Just depends on what's going on upstairs. Anybody have any comments or questions? We're
And
good to
one
go.
on the
Yes.
here at the end, if we can work on the, because I'm having trouble with where we would clear the denominators if they're going to have opposite signs for that application problem for the review to date number 3.
Ha, got it. I was kind of surprised that you didn't ask about that earlier, or somebody didn't ask about that earlier. Okay, so what was it? It was 24 over r minus 3?
And r plus 3, and then that was going to be equal to 6.
Okay, so what I'm going to do, the common denominator in this case is the r minus 3 and the r plus 3. So I'm going to write this out the long way because I know that we just don't do enough practice with this. So I'm going to write this by each of my terms. So r minus 3, r plus 3 times the 24 times the r plus 3. And then I'll have r minus 3 times r plus 3 times 6. That was really sloppy, but there it is. Okay, so I simply wrote the r minus 3 and the r plus 3 by every single term. Whew. And that's really what takes the longest time, is just writing that. Sorry, I just lost that. Yeah.
Okay, now we're back.
Still there?
I am at least.
It told me it was unstable. I don't know what's going on in the neighborhood. Okay, so the r minus 3 cancels. So from the first term, I've got the 24 times the r plus 3. Now from the next term, the r plus 3 would cancel, so I'll have the 24 times the r minus 3. And on the other side, there's nothing to cancel, so I'm going to go ahead and do a little bit of multiplication. I'm going to multiply and FOIL out these two together. Since they're the difference of squares, then we end up with r squared minus 9 times that 6. So I'll multiply the 6 in the next line. Okay, you want me to keep going, or are you good from there? Say the word. Keep going. Oh, I don't hear you, Rich. Looks like you're muted. It says Rich is talking, but I don't hear Rich talking. I'm going to assume you want me to keep going. So I have the 24 times the R. 24 times 3 is 72. I'll have a 24R. And then, okay.
Okay, I just came back. It had frozen for me again.
Yeah. See, I think we're all having, especially if you're in Pueblo, it makes sense that all of Comcast is having issues.
Right.
Okay, so the 72s are going to cancel out because one's positive, one's negative. 24 and 24 gives me a 48R equals the 6R squared minus 54. And because it's a quadratic, we know we need everything on one side, so I'm going to bring everything over to this side. So we'll have 0 equals 6R squared minus 48R minus the 54. Okay, now I don't know about you, but that looks really ugly. What I would do is divide everything by the 6's in order to make it easier to factor. So I'm just going to divide everything by 6. So that's going to give me 0 is equal to R squared minus what? 8R minus 9. And then it factors really easily. So yeah, I was keying it up and thought, oh, that's a little bit challenging for us because we haven't really done a lot of this. So
Well, and this was the one that I struggled on our first review date, where it was the exterior of the house. It's just when I see that
correct. You had those denominators,
yeah, if they're different, I don't know how to clear. Because I was thinking, well, my first thought is multiply by R and then clear the R, but then you're going to get -8 plus a +8. So
right,
R
which
is
is
going to end up equaling 0, and it can't be.
so does this make writing it as the R minus 3 and the R plus 3?
So you're just multiplying it by the opposite of what its original.
What it's missing, yeah. So you're multiplying by what it is missing, and since the 6 is missing both of them, that's why the 6 gets multiplied by both of them.
Both. Oh, okay. Yeah,
Okay.
that makes sense.
Okay. Any other comments or questions?
I'm okay.
Okay. Good, Christina.
Yeah.
You guys have a great day. Enjoy it.
You too.
Too.
We'll
Have
see
fun
you tomorrow.
shopping.